Good morning and welcome to this CS 103. This is linear algebra for computing applications. Today is going to be an introduction. A bunch of questions. Why learn linear algebra for computer science? Secondly, what is it anyway? So linear algebra has this word linear in it. So we have to kind of answer the question what linearity is, and also what does it apply to? What kind of mathematical object can be linear or non-linear? That will lead us to concepts of expressions and functions and variables, transformations and mappings and stuff like that. Then we will take a kind of a philosophical look on what equality means and what equations are, especially in our context of this course. The whole idea of linearity and the conditions of linearity and what it applies to will lead kind of naturally to the concept of vectors and matrices. So that's where I want to kind of bring you to today. I have divided the textbook and the course in 4 parts. The first 3 lessons is what I call numeric computations. Then we will move on to algebraic view. So in the first week today, we will just understand what linearity means essentially and how that leads to the concepts of vectors and matrices. Next week, we will go into vectors and matrices in more detail and their operations. The week after that, third week, we will look at transposes and determinants of matrices. So that will kind of complete the basic understanding of the numerical techniques that you might need. And after that, we will move on to the algebra of linear algebra, the algebraic part. What I mean by that is solving equations. As you will see later today, a matrix basically represents a set of equations and how to solve them, when you can solve them, and how you can determine the solvability conditions, etc. That will be the part of 4th and 5th weeks. And after that, part 3, we're going to go into a sophisticated understanding of spaces and what the spaces are and what it means to say that something is orthogonal, etc. The 9th week, we will be dealing with something called the fundamental spaces of matrices. The projection operation is an interesting operation. A projection into a space is actually something like minimization in calculus, and that also happens to be linear regression, which is a machine learning technique, which is quite impressive because without doing any kind of calculus kind of minimization, you can actually come up with a minimization which is used in linear regression. Best fit line to a set of points, that is a good example, right? Finding a best fit line, that is linear regression in 2 dimensions. And if you have 3-dimensional points, and if you are trying to find the best plane that fits the 3-dimensional points, that would be linear regression too. So obviously you can see that there is some kind of minimization of the errors of something. You might think that will come from calculus, but no, it actually comes from linear algebra in a very beautiful and elegant way. Part 4, advanced topics. More than that, these topics are actually very important in machine learning. Eigenvalue decomposition, eigenvalue computation will actually turn out to be the computation that Mr. Larry Page did in coming up with Google algorithm, the PageRank algorithm long time ago, which was $1 billion idea. That is just an eigenvalue computation, nothing more than that. Then singular value decomposition is like eigenvalue decomposition. I know that these things might sound very esoteric and confusing at this point, but when you come to it, you will see that those things are extremely useful. SVD, singular value decomposition, is the first thing that you do in machine learning when you have data. What's data? Data is a huge matrix. You want to understand certain directions in the space that is defined by that huge matrix, which are important to you. The principal, the important components of the data in a very easy, natural way, that will come from SVD, and that can be used in reducing the dimensionality of the data. So it's all extremely practical things in your life if you stay with computer science.